Hello, students. We're going to talk about side triangle congruence today. We are continuing to work on doing proofs, specifically proofs, two-column proofs. And we're working on a type of thinking called deductive reasoning. It's the type of thinking where every statement you make, you got to back it up with your evidence. And your evidence can be facts, it can be definitions of shapes or other stuff. It can be stuff we've already proven. It can be theorems. It can be postulates. It can be properties from algebra. So trying to strengthen your brain's ability to back up your claims. So what do we see in this picture? I see a triangle. What kind of triangle? Can we name the triangle? What else do you see? All three sides are different. What else do we see? What's it called when all three sides are different? Good. What else do we see? Is it acute or obtuse? Looks like all those angles are smaller than 90, so it looks acute. We see that it has three sides marked. So line segment ED has a mark on it. Line segment EF has a mark on it. And line segment FD has a mark on it. So what three pieces of information do we have markings on in this problem? We have markings on all three sides. So we're going to call this a side situation. All three sides have a mark on it. So this triangle is showing you a side, and another side. Okay, so this slide is showing us that there is a composition of rigid motions that would map triangle ABC onto triangle EFD, or DEF, excuse me. So there is a lot of interesting and kind of complicated math. If you want to go really deep with compositions, we can look through this. Let's just look through it super quickly though. So the deep, somewhat complicated way to say that these two triangles are the same size and shape through a proof by transformations would look like this. First, you would translate the triangle so that B would be onto E. So what did they do? They moved they put B onto E. Okay, they did that first. The next thing they did was they rotated, maybe I'll put this up here. So that's the first thing they did. The next thing they did was, oops, I lost it. Yeah, the next thing they did was they rotated it so that point E matched up with the side B prime, C prime. Okay, so they rotated it until the triangle is matched up on top of each other. Okay. After that, they did this complicated thing, which says, to show that A double prime does in fact match up onto D, we're going to pretend for a second like they don't match up. So pretend like this one is kind of like not exactly fitting on the other one, even though it's weird because we already know they fit. So we're going to pretend like they don't fit. So in this picture, we see it's kind of like a sandwich, and this one's kind of on top of that one. All right. Then we're going to say, and I know I'm not teaching this very well, so we're just looking at what it would look like if you were going to do a proof with transformations. Okay, then it says by the isosceles triangle theorem, the angles would be matched up. Okay. We could spend a lot more time talking about this, which I don't have right now. So there's this last statement is kind of interesting. This is called a proof by contradiction. So they say there's all this stuff here, but it contradicts the fact that that angle is supposed to be smaller than the other one, which means that the triangles are supposed to line up on each other. And because of that, we are allowed to say that the triangles are in fact perfectly congruent. So this is really interesting, really complicated. All you need to know is that these triangles are going to match up, and this is a proof of why. All right, we're going to do this, which is a 2-column proof. And it says we are supposed to prove that if you have a picture that looks like this, if you have this figure, I want you to prove that the triangles are congruent. So if we have the figure as marked, this is one on the worksheet that I'm asking you to do. You are supposed to be able to prove that triangle JKL is the same size and shape as triangle, let's see if I get it right, the order, JKNP. Yeah. And what do we put on this side? We put our statements. That's how a 2-column proof works. And on this side is our reasons, our evidence for why we know this is true. This is how we convince people and win our argument. So the first statement, and this is a really straightforward 4-stepper. The first statement I'm going to look at, I'm going to see line segment JL and line segment MP have the same mark. So line segment JL matches up, is the same size and shape as line segment MP. How do I know that? Because it was marked. They have the same mark on them, so that's given in the figure. The next thing we're going to do is look at the next. So that one had 1 mark. Now I'll do the 2 marks, just kind of keep it organized. I think I'll do KL. Line segment KL is the same size and shape as line segment NP. How do I know that's true? What's my evidence? Well, it's given. You could point to the picture and say, hey, look, I see that they both have 2 marks. And then we can say line segment JK is the same size and shape as line segment MN. How do I know that? How would you tell someone that that's true? You'd say, well, look at line segment JK, it has 3 marks. Look at line segment MN, it also has 3 marks. That is given. They match up because they're marked the same. Then we say, okay, if all 3 sides are the same, we are allowed to say the triangles are congruent. I just showed you that all 3 sides are the same, therefore, the triangles are congruent. Okay, this is called a theorem, and it's a theorem that we can use when we're trying to show shapes are the same size and shape, triangles specifically. Okay, here's a little bit more complicated one. So they're not all that straightforward. Sometimes you have to work for them a little bit more. And this one we are going to engage with. And I actually made this one up. There's a like problem. Okay, statements go over here. And reasons go over here. This is how you set up a 2-column proof. You copy the picture, you tell me what's given, you tell me what you're trying to prove. You create 2 columns On this side, you write the word statements, and on this side, you write the words reasons. And I don't actually know how many steps is in this proof, but it's definitely going to be more than 4. So let's take it piece by piece and see if we can figure out. There's 2 little tricks in this one. Let's see if we can figure out how these work. So first I'm going to read this. M is the midpoint of line segment QB. The 2 triangles are isosceles. And triangle QRM is congruent to triangle BLM. Does it look like they're congruent? Yeah, mostly. Okay, now we're going to actually have to prove it. So I can start with the given information. Let's start with the first statement, and I'm just going to rewrite that right in here in my proof. M is the midpoint, I'm going to abbreviate, of line segment QB. How do I know that? Because it's given. If M is the midpoint, can someone look up the definition of midpoint? Maybe you can Google it. What's the definition of midpoint? Something from topic 1 that we talked about. So everything we learned is coming together now. Okay, so it says that the midpoint of a line segment is the point that divides the segment into 2 congruent parts. So what I'm going to do is I'm going to go get a color here. So M is the point that divides the segment into 2 congruent parts. That means this side of the line segment and this side of the line segment are congruent. I don't like how that came out. So they get the same mark. So now I'm going to mark that. I'm going to write that right down here. I'm going to write that line segment QM has the exact same mark as line segment BM. How do I know that? How did I know those 2 parts were the same? Because I know the definition of midpoint. I looked it up. I know that the midpoint says that it's the point that divides the segment into 2 congruent parts. So that is, I used the definition of midpoint as my reason. Okay, and if I'm keeping track, I just showed that 1 pair of sides is congruent on this figure. The next thing I'm going to do, I could do this because it was given in the figure that QR is congruent to BL. I'm going to save that for a second. There's sort of a strange thing that happens here. I'm going to go get my second piece of given information here, which is triangle QRM and triangle BLM are isosceles. And that was given to me in the problem. Someone told me that those 2 triangles are isosceles. If a triangle is isosceles, what does that mean? I could go look up the definition of isosceles. And the definition of isosceles says that 2 of the sides are congruent. So what I'm going to do here is I'm going to say that line segment QR is congruent to line segment RM. I'm also at the same time going to say that line segment BL, oops, that's triangle BL. I want to say line segment BL. Line segment BL is the same size and shape as line segment LM. Okay, I'm going to go mark that with a color. So I'm going to use a different color. I'll use this yellow here. So line segment QR gets the same mark as line segment RM. So it already had 1, so I have to use 1 for here as well. And line segment BL gets the same mark as line segment LM. So I have 1 for there. Okay. Why did I know that these 2 were the same and these 2 were the same? Because I know the definition of isosceles triangles. definition of isosceles. All right, let's continue. So I said that QR is the same as RM. I said that BL is the same as LM. I also know originally what was given in the figure is that QR is the same as BL. Line segment QR is the same size and shape as line segment BL. Okay, that was given. Okay. So well, I'm going to do something called, so QR is the same as RM. BL is the same as LM. QR is the same as BL. Therefore, using something called the transitive property, I can say that line segment RM is the same as line segment LM. It might help you to think of it as a number. So if QR is 5, then RM is also 5. If BL is 5, then LM is also 5. And because of that, and because we know QR is the same as BL, they're both 5, we can say that RM is the same as LM. They're both 5. That's slightly complicated, but this is the way this one works. And proofs, it's okay. It's okay if you don't know a reason. You can come back to class tomorrow and be like, I think it works like this, but I didn't really know what reason to put here, and I can help you out with that. So the reason for this is called the transitive property. You could also say substitution sometimes, depending on, depending on the situation. Okay, so let's look back at our proof. Did I show these two pairs of sides were congruent? Yes. Did I show that these two pairs of sides were congruent? Yes. Did I show that that third pair of sides were congruent? Yes. Okay, did I get enough information to say that triangle QRM is the same size and shape as triangle BLM? Well, I did. I used side, 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 triangle congruence theorem. Well, let's look at the theorem. It says, if you can show that the 3 sides of one triangle match up perfectly to the 3 sides of another triangle, then you are allowed to say that the 2 triangles are congruent. And that's what we just did. That is one of the ways to show that 2 triangles are congruent. We have 2 ways so far. Actually, we have 3. 2 ways with the letters that we've talked about. All right, be good, do your homework, ask questions. Have a good day.